Chapter 10 Straight Lines Miscellaneous Exercise. Question number 17. The hypotenuse of a right angled triangle has its ends at the points 1, 3 and minus 4, 1. Find an equation of the legs perpendicular sides of the triangle. Let this be 1, 3 and this be minus 4, 1. With this as the hypotenuse, we can draw infinitely many right triangles. We know that on the diameter of a circle, infinitely many triangles can be drawn, which are right triangles. The angle in a semicircle is 90 degrees. So, if we draw a circle with these two given points as diameter, then infinitely many right triangles can be drawn. Now, we will find the legs, the perpendicular sides, which are horizontal lines and vertical lines. Let us draw a horizontal line and a vertical line. Let this be C. This is 90 degrees. Equation of horizontal and vertical lines are easy to find. AC is a horizontal line which is parallel to x-axis. Therefore, equation of AC will be y is equal to some constant. That constant is the y coordinate of the point A, which is 1. Let us now write equation of BC. It is a vertical line which is parallel to y-axis. Equation will be x is equal to some constant. It passes through the point B. The x coordinate of this point is 1. These are the equations of two perpendicular sides with AB as the hypotenuse. Similarly, we can find another set of answers by drawing the horizontal and vertical lines above this line AB. We will take this as C dashed. Therefore, equation of BC dashed is, it's a horizontal line parallel to x-axis. Equation will be y is equal to, it passes through the point B. We will write the y coordinate of B point, which is 3. And the corresponding perpendicular side is equation of AC dashed, which is a vertical line parallel to y-axis. The equation will be x is equal to, it passes through the point A. We have to write the x coordinate of A point, which is minus 4. This is another set of answer. Question number 18, and it is an important question. Find the image of the point 3, 8 with respect to the line x plus 3y equal to 7, assuming the line to be a plane mirror. Let this be the given line x plus 3y equal to 7. Let P be the given point 3, 8. Let us draw a perpendicular from P to the line. Let this be L point and this be P dashed, which is the image of P point. Distance PL will be equal to P dash L, that is L will be the midpoint of PP dashed. We have to find the point P dashed, which is the image of P point. We will take P dashed as x dash y dashed. L is the midpoint of PP dash. Therefore, L point is x dash plus 3 divided by 2 and y dash plus 8 divided by 2. Now, this point L lies on the line x plus 3y equal to 7. Therefore, we will substitute this point x dash plus 3 divided by 2 plus 3 times y dash plus 8 divided by 2 is equal to 7. We will multiply by 2. 3 times y dash plus 8 is equal to 2 7s are 14. X dash plus 3 y dash plus 24 is 14, x dash plus 3y dash, it is 14 minus 27, which is minus 13. This is our first equation. We have two unknown quantities, we need one more equation, and we know that pp dashed is perpendicular to the given line. We will use the perpendicularity condition. Slope of the line x plus 3y equal to 7 is minus a by b. Slope of pp dashed is y2 minus y1 divided by x2 minus x1 formula. Now these two are perpendicular lines. m1, m2 should be minus 1. Minus 1 by 3 times y dash minus 8 divided by x dash minus 3 should be minus 1. Therefore, y dash minus 8 is 3 times x dash minus 9, 3x dash minus y dash is equal to 1. This is our second equation. We will solve 1 and 2 and find x dash y dash. Multiply the first equation by 3. 3x dash plus 9y dash is equal to minus 39. And the second equation is 3x dash minus y dash is 1. We will change the sign so that the first two terms are getting cancelled. 10y dash is equal to minus 40. Therefore, y dash is minus 4. We will substitute in the first equation. X dash minus 12 is minus 13. Therefore, x dash is minus 1. Therefore, the image is minus 1, minus 4. Question number 19. If the lines y equal to 3x plus 1 and 2y equal to x plus 3 are equally inclined to the line y equal to mx plus 4, find the value of m. This is the first equation, second and third. We will take the slope of the first line as m1. This is of the form y is equal to mx plus c, where m is the slope. So directly we are able to write the slope 3. And here y is half x plus 3 by 2. Therefore, slope of this line is half. And this is m. The slope is m. Lines 1 and 2 are equally inclined to the third line. So, tan theta formula, absolute value of m2 minus m1 divided by 1 plus m1 m2. Tan of angle between the first two lines is absolute value of 3 minus m divided by 1 plus 3m is equal to angle between second and the third. If angles are equal, tan of those angles are also equal. Half minus m divided by 1 plus half m. We will simplify the right hand side by taking LCM. 1 minus 2m divided by 2 plus m. LCMs will get cancelled. We will remove the absolute value sign by writing plus or minus sign. 3 minus m divided by 1 plus 3m equal to, we can write the plus or minus sign on any one side. We have two equations to solve. 3 minus m divided by 1 plus 3m equal to, with plus sign, 1 minus 2m divided by 2 plus m, and the other equation is with the minus sign. We will cross multiply. 6 plus 3m minus 2m minus m square is equal to 1 minus 2m plus 3m minus 6m square. 6 plus m minus m square is equal to 1 plus m minus 6m square. 5m square is equal to minus 5. We get m square as minus 1, which is not possible. Square of a number cannot be negative. Now we will solve the second equation. We will cross multiply. 6 plus 3m minus 2m minus m square is equal to minus of 1 minus 2m plus 3m minus 6m square. 6 plus m minus m square is equal to 1 plus m minus 6m square. There is a negative sign, which is minus 1 minus m plus 6m square. Therefore, we get 7m square minus 2m minus 7 is equal to 0. We have a quadratic equation in m. We cannot split the middle term. We will use the formula method. M is minus b plus or minus square root of b square minus 4ac divided by 2a, which is equal to minus of minus 2 plus 2 plus or minus root of b square minus 4 times 7 times minus 7. Minus and minus will become plus, divided by 2a is 14. This is equal to 2 plus or minus 4 is common. It can be taken out as 2. 1 plus 49 divided by 14. Here 2 is common. 1 plus or minus square root of 50 divided by 14. 1 plus or minus root 50 is 5 root 2 divided by 7. Therefore, the answer is m is equal to 1 plus or minus 5 root 2 over 7. Question 20. If sum of the perpendicular distances of a variable point p xy from the lines x plus y minus 5 equal to 0 and 3x minus 2y plus 7 equal to 0 is always 10, show that p must move on a line. We know the formula to find the distance of a point from a line. Absolute value of a x1 plus b y1 plus c divided by square root of a square plus b square. The point P is xy. We will find the distance of this point P from the first line, which is x plus y minus 5 divided by root of a here is 1, b is also 1, root of 1 plus 1, which is absolute value of x plus y minus 5 divided by root 2. Let d2 be the distance of P point from the second line, which is absolute value of 3x minus 2y plus 7 divided by root of a square, which is 3 square plus minus 2 the whole square. Absolute value of 3x minus 2y plus 7 divided by root 13. Now the total is 10. d1 plus d2 is 10. Therefore, absolute value of x plus y minus 5 divided by root 2 plus absolute value of 3x minus 2y plus 7 divided by root 13 is equal to 10. Multiply this equation by root of 26. We get root 13 times absolute value of x plus y minus 5 plus root 2 times absolute value of 3x minus 2y plus 7 equal to 10 times root of 26. When we remove the absolute value sign, we have 4 different cases. The first is both the terms positive, second case both negative, third first one positive, the next second one negative, or the fourth one first one negative, second one positive. In all the 4 cases, we will be getting linear equations in x and y which are all straight lines. First case, we will take x plus y minus 5 and 3x minus 2y plus 7 both positive. We get root 13 times x plus y minus 5 plus root 2 times 3x minus 2y plus 7 equal to 10 root 26. Since the numbers are positive, we need not write the absolute value sign. Now we will collect the x terms. X times root 13 plus 3 root 2 plus y times root 13 minus 2 root 2, and the constant terms minus 5 root 13 plus 7 root 2 minus 10 root 26 equal to 0. The second case, we will take both negative. We get root 13. To remove the absolute value sign for negative values, we have to put minus sign so that the number becomes positive. Minus root 2 times 3x minus 2y plus 7 equal to 10 root 26. We will write the x terms minus root 13 minus 3 root 2. Now y terms minus root 13 plus 2 root 2, and the constant terms 5 root 13 minus 7 root 2 minus 10 root 26 is equal to 0. This is also a linear equation in x and y. Now the third case, we will take x plus y minus 5 positive and 3x minus 2y plus 7 negative. So this is a positive number, we can remove the absolute value sign. And the second one is a negative value. To remove the absolute value sign, we have to put minus sign. X times root 13 minus 3 root 2 plus y times root 13 plus 2 root 2 minus 5 root 13 minus 7 root 2 minus 10 root 26 equal to 0. This is again a linear equation in x and y which represents a straight line. Now the last case, fourth one, we will take x plus y minus 5, a negative quantity, and 3x minus 2y plus 7, a positive quantity. So to remove the absolute value sign for negative numbers, we have to put minus sign. Minus root 13 times x plus y minus 5, and this is positive. So plus root 2 times 3x minus 2y plus 7 equal to 10 times root 26. X times minus root 13 plus 3 root 2 plus y times minus root 13 minus 2 root 2 plus 5 root 13 plus 7 root 2 minus 10 root 26 equal to 0. In all the 4 cases, the equations are linear equations in x and y, which are straight lines. Therefore, P moves on a line. Question 21. Find the equation of the line which is equidistant from parallel lines 9x plus 6y minus 7 equal to 0 and 3x plus 2y plus 6 equal to 0. These two are parallel lines. See the coefficients of x and y, they are proportional. So let this be 9x plus 6y minus 7 equal to 0, and let this be the parallel line which is 3x plus 2y plus 6 equal to 0. We have to find the equation of a line which is equidistant from these two lines. So mid-parallel line. We will take an arbitrary point P on this line which we are going to find as x comma y. Let us draw a perpendicular. PQ must be equal to PR. PQ is the perpendicular distance of P point from the first line, which is absolute value of 9x plus 6y minus 7 divided by root of a square. 9 square is 81 plus 6 square is 36 equal to PR is the perpendicular distance of P from the second line, which is absolute value of 3x plus 2y plus 6 divided by square root of 3 square 9 plus 2 square is 4. 81 plus 36, 117. Let us do prime factorization. It is 3 root 13. Absolute value of 9x plus 6y minus 7 divided by 3 root 13 equal to absolute value of 3x plus 2y plus 6 divided by root 13. We will remove the absolute value sign by writing plus or minus sign on any one side and take 3 to the other side. We have two equations to solve. We will solve first with a positive sign. 9x plus 6y plus 18. So we don't have any solution. Minus 7 is equal to 18, not possible. Now we will solve the second equation by taking the negative sign. Minus 9x minus 6y plus 7 equal to 9x plus 6y plus 18. We get 18x plus 12y plus 11 equal to 0. Therefore, the required line equation is 18x plus 12y plus 11 equal to 0. Question 22. A ray of light passing through the point 1, 2 reflects on the x-axis at point A and the reflected ray passes through the point 5, 3. Find the coordinates of A. This is 1, 2. This is 5, 3. The ray passes through 1, 2. This be the point A. It lies on the x-axis, so we will take it as x, 0. And the reflected ray passes through 5, 3. We will take this point as B, this as C. Let us draw a perpendicular through A, perpendicular to x-axis. We know that the angle of incidence is equal to angle of reflection. Therefore, this angle will be 90 minus theta. Let A be x0 and B is 1, 2, C is 5, 3. We know that angle of incidence is equal to angle of reflection. I will take this as L. angle LAB is equal to angle LAC. Angle CAX will be 90 minus theta and angle BAO is also 90 minus theta, this angle. And angle BAX will be 180 minus BAO angle, which is 90 minus theta, which is 90 plus theta. Now slope of CA, which is tan of 90 minus theta, equal to, we will use the formula y2 minus y1 divided by x2 minus x1. We will use the points C and A, 3 minus 0 divided by 5 minus x. Tan 90 minus theta is cot theta. Now similarly, we will find slope of BA, and BA makes an angle of 90 plus theta with the positive direction of x-axis. Tan of 90 plus theta is the slope. We will equate it to the slope using the 2 points B and A. 2 minus 0 divided by 1 minus x, and tan 90 plus theta is minus cot theta. 90 plus theta is a second quadrant angle. Therefore, cot theta is minus 2 divided by 1 minus x. Equation 1, equation 2. We will equate cot theta. We get 3 divided by 5 minus x is equal to minus 2 divided by 1 minus x. 3 minus 3x is equal to minus 10 plus 2x. 5x is 13. Therefore, x is 13 divided by 5. Therefore, the point A is 13 divided by 5, 0. Question 23. Prove that the product of the lengths of the perpendiculars drawn from the points root of a square minus b square 0 and minus root of a square minus b square 0 to the line x divided by a cos theta plus y divided by b sin theta equal to 1 is b square. We will write this equation of the line by multiplying it by AB. We get bx cos theta plus ay sin theta minus AB equal to 0. We will find the distance d1 from the first point to the line. Using the formula, absolute value of ax1 plus by1 plus c divided by root of a square plus b square, which is absolute value of b into x is root of a square minus b square cos theta plus y coordinate is 0 minus ab divided by square root of coefficient of x is b cos theta and coefficient of y is a sin theta. Now distance d2 of the second point from the line, absolute value of b times the x coordinate is minus root of a square minus b square cos theta, y coordinate is 0 minus ab divided by root of the same denominator, because we are using the same line. And we have to prove that product of these two lengths is b square. So we will find d1 times d2, absolute value of b times root of a square minus b square cos theta minus ab divided by root of b square cos square theta plus a square sin square theta times absolute value of minus b into root of a square minus b square cos theta minus ab divided by root of b square cos square theta plus a square sin square theta. We will multiply and write absolute value of minus b square times a square minus b square cos square theta minus a b square root of a square minus b square cos theta, then plus a b square root of a square minus b square cos theta plus a square b square divided by b square cos square theta plus a square sin square theta. These two terms are getting cancelled. B square is common in the numerator. We will take it out. B square is a positive number. Minus a square cos square theta plus b square cos square theta and plus a square divided by b square cos square theta plus a square sin square theta. B square times, we will combine first and the third terms. A square is common, we get 1 minus cos square theta plus b square cos square theta divided by b square cos square theta plus a square sin square theta. Now the numerator is a square sin square theta. 1 minus cos square is sin square plus b square cos square theta. B square times, we can remove the absolute value sign because all terms are having square, so it is a positive number. Therefore, we can remove the absolute value sign. These two are getting cancelled. Therefore, the answer is b square. Question 24. A person standing at the junction crossing of two straight paths represented by the equations 2x minus 3y plus 4 equal to 0 and 3x plus 4y minus 5 equal to 0 wants to reach the path whose equation is 6x minus 7y plus 8 equal to 0 in the least time. Find the equation of the path that he should follow. Equation of this path is 2x minus 3y plus 4 equal to 0. There is another straight path whose equation is 3x plus 4y minus 5 equal to 0. The person is standing at this junction. We will take this point as P. We can find the point P by solving these two equations. The person wants to reach the third path in the least time. This is the third path, say, whose equation is 6x minus 7y plus 8 is equal to 0. Time taken will be least when the distance covered is the least. So, the least distance is the perpendicular distance. We will take this as equation 1 and this as 2 and this as 3. Solving 1 and 2. We will multiply the first equation by 3. 6x minus 9y plus 12 is equal to 0. Multiply the second equation by 2. 6x plus 8y minus 10 is equal to 0. We will change the sign. These two are getting cancelled. Minus 17y plus 22 is 0. Therefore, y is 22 over 17. We will substitute in the first equation to find the x coordinate. Minus 66 over 17 plus 4 is equal to 0. 2x is 66 divided by 17 minus 4. LCM is 17. 4 times 17 is 68, which is minus 2 divided by 17. Therefore, x is minus 1 divided by 17. Therefore, P point is minus 1 divided by 17 and 22 divided by 17. We will take the foot of the perpendicular drawn from P as L. We have to find the equation of PL. We will write slope of the given line 6x minus 7y plus 8 is equal to 0. The slope is minus a divided by b minus 6 divided by minus 7, which is 6 divided by 7, from which we can write the perpendicular slope. PL is a perpendicular line, therefore slope of PL, negative of its reciprocal, using the formula m1 into m2 is minus 1. And it passes through the point P. Therefore, we can write the equation of PL. We will use point slope form. The formula is y minus y0 is equal to m times x minus x0. Y minus y coordinate of P point. Slope of PL is minus 7 over 6 times x minus of minus 1 by 17. 17 is the LCM. 17y minus 22 is equal to minus 7 divided by 6. Here also 17 is the LCM. We will cross multiply. 17 times 6, 102. 102y minus 132 minus 7 times 17 minus 119x minus 7. 119x plus 102y is equal to 132 minus 7, 125. This is the equation of the path that he should follow. Example 23. Show that the area of the triangle formed by the lines y equal to m1x plus c1, y equal to m2x plus c2 and x equal to 0 is c1 minus c2 the whole square divided by 2 times absolute value of m1 minus m2. We will take this as first equation, second and the third equation. We will solve these three equations and we will find the vertices of the triangle formed. Solving the first two equations. First equation is y is equal to m1x plus c1 and the second equation is y equal to m2x plus c2. We will change the sign. These two are getting cancelled. 0 is equal to m1 minus m2 times x plus c1 minus c2. Therefore, x coordinate is minus of c1 minus c2 divided by m1 minus m2, which is c2 minus c1 divided by m1 minus m2. We will substitute in the first equation and find the y coordinate. Y is equal to m1 times the x coordinate, which is c2 minus c1 divided by m1 minus m2 plus c1. The LCM is m1 minus m2. The numerator is m1c2 minus m1c1 plus m1c1 minus m2c1. Therefore, the y coordinate is m1c2 minus m2c1 divided by m1 minus m2. Therefore, the point of intersection of the first two lines is c2 minus c1 divided by m1 minus m2, and the y coordinate is m1 c2 minus m2 c1 divided by m1 minus m2. Now solving second and the third equations. Y is equal to x coordinate is 0. So m2 times 0 plus c2. So y is c2 and the x coordinate is 0. Therefore, the point of intersection is 0, c2. Now solving first and the third equations. Y is equal to m1 times 0 plus c1. Therefore, y coordinate is c1, x coordinate is 0. The point of intersection is 0, c1. Or from the second and the third equations, the y-intercepts are c1 and c2, and x is equal to 0 is the equation of y-axis, from which we can write these 2 points of intersection, or we may solve like this and calculate. Now we have 3 vertices, first, second, third. We have to find the area of the triangle formed by these 3 vertices. Therefore, area of the triangle is half into absolute value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. We will take this as x1 y1, the second point as x2 y2, and the third one as x3 y3. Therefore, the area will be half into absolute value of c2 minus c1 divided by m1 minus m2 times y2 minus y3 plus x2 is 0, second term is 0, x3 is 0, therefore third term is also 0. We get half into absolute value of c2 minus c1 the whole square divided by m1 minus m2. The numerator has whole square, which is already a positive number, so no need to write the absolute value sign, divided by the denominator is absolute value of m1 minus m2. Square units. This is the area of the triangle formed. Example 24. A line is such that its segment between the lines 5x minus y plus 4 equal to 0 and 3x plus 4y minus 4 equal to 0 is bisected at the point 1, 5. Obtain its equation. Let this be the first line, whose equation is 5x minus y plus 4 equal to 0, and this be the second line, whose equation is 3x plus 4y minus 4 equal to 0. Let this be the line segment between these two lines, and it is bisected at the point 1, 5. We will take this point as M. Let this point be A, whose coordinates are alpha 1, beta 1, and let this point be B, whose coordinates are alpha 2, beta 2. And M is the midpoint of AB. Let A be alpha 1, beta 1, B point be alpha 2, beta 2. And we have to find the equation of the line AB. A point lies on the first line, 5x minus y plus 4 equal to 0. So, it should satisfy that equation. 5 alpha 1 minus beta 1 plus 4 is 0. from which we can get beta 1. Beta 1 is 5 alpha 1 plus 4. This is our first equation. The point B, which is alpha 2 beta 2, lies on the second line, which is 3x plus 4y minus 4 equal to 0. Therefore, B should satisfy this line equation. 3 alpha 2 plus 4 beta 2 minus 4 equal to 0. From this, beta 2 is 1 by 4 times 4 minus 3 alpha 2. This is the second equation. We have 4 unknown quantities, alpha 1, beta 1, alpha 2, beta 2. So, we need 4 equations to solve. We got 2 equations. To get 2 more equations, we will use the midpoint M. M is the midpoint of AB. Alpha 1 plus alpha 2 divided by 2, beta 1 plus beta 2 divided by 2, this is the midpoint formula, and this is equal to 1, 5. By equating the x coordinates, we get alpha 1 plus alpha 2 divided by 2 as 1 and beta 1 plus beta 2 divided by 2 as 5. Alpha 1 plus alpha 2 is 2. This is the third equation, and similarly beta 1 plus beta 2 is 10. This is the fourth equation. Now we will substitute 1 and 2 in the fourth equation. Beta 1 is 5 alpha 1 plus 4 from the first equation, and beta 2 is 4 minus 3 alpha 2 divided by 4 from the second equation, and this total is 10. We will multiply the whole equation by 4. 20 alpha 1 plus 16 plus 4 minus 3 alpha 2 is 40. Don't forget to multiply the other side by 4. We get 20 alpha 1 minus 3 alpha 2 is equal to 40 minus 20, which is 20. This is our fifth equation. We will solve third and the fifth equations. Let us multiply the third equation by 3. We get 3 alpha 1 plus 3 alpha 2 is equal to 6. These two terms are getting cancelled. 23 alpha 1 is 26. Therefore, alpha 1 is equal to 26 over 23. We will substitute this in the first equation to find beta 1. From the first equation, beta 1 is 5 alpha 1 plus 4, which is 5 times 26 over 23 plus 4. 23 is the LCM, 130 plus 92. 222 over 23. Therefore, A point is alpha 1 is 26 over 23 and beta 1 is 222 over 23. And we know M point on the line AB, which is 1, 5. We have 2 points to find the equation of AB. We don't need the third point. We need not calculate alpha 2 beta 2. So 2 points are enough to find the equation. Therefore, equation of line AB using 2-point form, y minus y1 is equal to y2 minus y1 divided by x2 minus x1 times x minus x1. This is the formula. We will take A as x2 y2 and M as x1 y1. Because A point has bigger values, we will take it as x2 y2. Y minus y1 equal to 222 over 23 minus y1 is 5 divided by x2 is 26 over 23 minus x1 is 1 times x minus x1. Y minus 5 is equal to, we will take LCM 23. 5 times 23 is 115 divided by 26 minus 23. 23 LCM will get cancelled times x minus 1. 222 minus 105. 7, 0, 1. 107 divided by 3 times x minus 1. Multiply by 3. 3y minus 15 is 107x minus 107. The equation is 107x, taking y term to this side, minus 3y is equal to 107 minus 15. Therefore, 107x minus 3y is equal to 92.